Hello and welcome to week 2 of Lab in a Bag. This week we're going to explore and learn about the chemistry behind slime. But first, some background information about today's activity. A solid is one of the three main states of matter, along with liquid and gas. Matter is anything that takes up space and has weight. Something that is solid will keep its shape as the tiny particles that make it up are packed closely together, like ice. Something that is a liquid will take the shape of the container as the tiny particles that make it up aren't packed as closely together and can flow and move. So something like this is like water. Sir Isaac Newton is famous for developing many scientific theories. He described how normal liquids or fluids behave, and he observed that they have a constant viscosity or flow. This means that their flow behavior only changes when the temperature or pressure changes. So for example, water freezes and turns into a solid or ice at 32 degrees Fahrenheit and turns into a gas at 212 degrees Fahrenheit. But within this temperature range, water behaves like a normal liquid with the same flow or viscosity. So with a Newtonian fluid, if you apply a force to it, like try to hit water with a hammer, it does not affect how it flows and the water remains the same. So non-Newtonian fluids mean that they don't follow Newton's rules and they behave differently. These strange fluids change their viscosity or their flow under stress. So if you apply a force to it, such as you try to hit or shake or jump on them, the sudden application of stress can cause them to act thicker like a solid, or in some cases go the opposite way and become more runnier. Once you remove the stress or let them sit still or only move slowly, you'll notice that they'll return to their earlier state. Some examples that you might see in and around your house and community is like ketchup, honey, slime, and some types of waste. Do you ever notice that when you grab some ketchup and try to turn the bottle upside down, nothing really comes out, or it's really slow to come out? So what do? You shake or you hit the bottle. This causes the ketchup to become more liquid and you can easily squirt some out. In this case, the sauce's viscosity or flow decreases and it gets runnier with the applied stress. Today's aim, you'll create some edible homemade slime and learn about non-Newtonian fluids. So grab your lab in a bag, grab your friends, grab your grown-ups, and let's get started. Gather all your materials. You'll need 6 jumbo marshmallows, 1 tablespoon or a packet of oil, half to 1 tablespoon of cornstarch powder, a microwave or stove, a microwave safe bowl or pot, a spoon, and oven mitts. Step 1. Wash your hands and make sure everything you use today is clean. This is especially important if you would like to eat the marshmallow slime once you're done. Step 2. Combine 6 jumbo marshmallows and 1 tablespoon of oil in a microwave safe bowl or add it to a pot. Step 3. Microwave on high for 30 seconds to 1 minute. The time depends on the power of your microwave. Or you can heat your pot on the stove using a low to medium temperature until the marshmallows have melted. Step 4. Add half a tablespoon of the cornstarch powder to the marshmallows and cooking oil. Please be very careful, this mixture will be hot, so use your oven mitts. Step 5. Mix everything together that is in the large mixing bowl with a mixing spoon. You can mix everything together with your hands once it's cool enough. Before playing with your slime, you might want to dust your hands with a little bit of the cornstarch or rub them with oil to prevent them from sticking. The slime will gradually thicken over the next few hours until it gets tough and hard to stretch. It's time to make some notes and observe like a scientist. So what do you notice about the slime so far? What does it feel like? And what happens when you leave your slime alone for a few minutes? Write down your observations in your notebook. Step 6. Add more cornstarch to the marshmallow slime and then mix with your hands. So what do you notice about the slime now that you've added more cornstarch? What does it feel like compared to before? So what is happening? Marshmallows are made of a mixture of sugar, gelatin, which is what we make jelly out of, and water. Gelatin likes to stick to itself when it's cooled, and this is the reason why marshmallows are firm or solid. But when you heat the gelatin, the bond between the gelatin gets loose and the marshmallow starts to flow more like a liquid and become slimy. We added cornstarch, which helped to turn our marshmallow mixture into a non-Newtonian fluid. Cornstarch creates bonds or links with itself, which allows it to flow like a liquid under no stress and act like a solid under stress. Wondering why your mixture is so sticky? The amount of sugar is responsible for this, so please make sure not to eat too much of this as it's quite sweet. If your mixture is too sticky or liquid, you can add more oil and cornstarch, which helps fight the stickiness. The more you add and the more you knead it with your hands, you're applying force or stress, and the more it will act like a putty or a solid. You can see your non-Newtonian fluid in action here. So when you stir or play with the slime, you're applying stress, and the slime starts to act like a solid and becomes more thicker or more viscous, and it's not taking up the shape of its container. But as you see, when Cole leaves his slime alone and applies no stress, it starts to act like a liquid and becomes more runny and takes the shape of the container. So we've made some fun marshmallow slime and learned a little bit more about non-Newtonian fluids. But why do they matter? If you remember in the Lorax read along with Cole, the Lorax was annoyed with the Onceler because his machines were making a lot of waste and polluting the water.
What's more, snapped the Lorax. His dander was up. Let me say a few words about Gluppity-Glup. Your machinery chugs on, day and night without stop, making Gluppity-Glup. Also Sloppity-Slop. And what do you do with that leftover goo? I'll show you. You dirty old Onceler man, you. You're glumping the pond where the humming fish hummed. No one can hum, for their gills are all gummed. So I'm sending them off. Oh, their future is dreary. They'll walk on their fins to get woefully weary in search of some water that isn't so smeary.
We all create waste every day, and some of it behaves similarly to our non-Newtonian fluid, aka slime. So where does our waste go, and how do we make sure that our rivers and ponds don't end up like in the Lorax? Wastewater engineers deal with non-Newtonian fluids we create every day, and this is called wastewater sludge. Tune in next week where we will visit Elkhart Public Works and Utilities and go on a behind-the-scenes tour where we learn about what happens to the stuff we put down the drain and how we protect our river system from pollution. In the meantime, check in on your recycled sprout house and make sure you're giving your seeds everything they need to germinate. So make sure that they've got somewhere warm to stay, water and oxygen. If you have any questions, please let us know. Make sure to log into Edmodo where you can see additional videos, interact with us and enter our prize pool.